In this video, I'm going to go over competitive and uncompetitive inhibition. In competitive inhibition, the substrate and the inhibitor are competing for the same active site. So at a given substrate concentration, some of those active sites are going to be occupied by the inhibitor, so usually we'll have a lower reaction rate whenever that inhibitor is present. However, if we can add enough substrate that the inhibitor never really has a chance to bind to the active site, then we can get all of our enzymes producing products and we can still reach that maximum reaction rate. So that means our Vmax is unchanged, but we will require more substrate than normal to reach half of Vmax compared to when we don't have the inhibitor present. So competitive inhibitors don't change the Vmax, but they raise the Km. For uncompetitive inhibition, the substrate has to bind first and then the inhibitor can bind. And once the inhibitor binds, the substrate can't leave. The inhibitor will bind to an allosteric site, which means away from the active site. And a lot of places are going to show it binding really close to the active site, but it doesn't necessarily have to be that way. As long as it locks the substrate into place and it binds after the substrate binds, it's an uncompetitive inhibitor. The reaction drawn below shows that the inhibitor only binds after the enzyme substrate complex is formed. And once the inhibitor binds, that enzyme cannot make any product, so that's going to lower the reaction rate. And the reaction rate is lowered at all substrate concentrations, and unlike competitive inhibition, we can't just add more substrate to overcome this because the inhibitor binds after the substrate binds. So uncompetitive inhibitors lower Vmax. To understand what happens to Km, look at the reaction below. Whenever the inhibitor binds, we drive this reaction this way. So while the number of enzymes that are producing product is going down, we are actually driving this reaction to the right according to Le Chatelier's principle. So the remaining enzymes are actually more efficient at creating the enzyme substrate complex, which also drives the reaction to create more products. So we're actually creating more products per enzyme than we did without the inhibitor. So that means we're actually able to reach half of Vmax with less substrate than the uninhibited enzyme was able to. So that means that uncompetitive inhibition lowers both Vmax and Km.